start with the basics. Okay, I'll spend some time on this slide, start a little bit slowly, and I will pick up the pace as we go along. All right, so let's understand the concept of sigma in this Six Sigma word, right? It does sound a bit fancy. The concept behind it is very simple. Sigma measures the variation in a process or a product. That's it, right? So the greater the sigma level, the lower the variation in a product or process. This is important. So again, just to repeat, the greater the sigma level, the lower the level of variation in a product or process, because typically people think it's other way around. And of course, needless to mention, lower levels of variation translate to higher levels of customer satisfaction, excuse me, because nobody likes variation, right? So as you can see in the schematic, products of a two Sigma company will be 69.1% non-defective, whereas products of a Six Sigma company will be 99.99966 to be very precise, non-defective, right? Now just to clarify, if some process, let's say, generates on an average, I don't know, let's make something up, 30% repair, right? But the inspection department is really good. They catch all the bad parts and sends them to repair area, get them repaired. And so finally, the process eventually will, let's say, generate 100% good parts. Not even a single bad part sneaks through, right? But still, it is not a Six Sigma process by any means. Why? Because the issues causing the rework, right, are not addressed. The root cause is not addressed. In other words, the process is still unreliable. And you see, this is a good example of connection between a lean and a Six Sigma. Six Sigma reduces variation and makes the process more reliable, right? So it basically results in reducing the rework. And guess what? Lean includes the rework in its famous list of 7 wastes, or mood as they call it, right? So really, lean and Six Sigma methodologies complement each other, right? Okay, I'll touch upon this fact again, I guess in the last part of the presentation, but let's keep moving. So let's jump right into the basic framework of Six Sigma, okay, which involves, as many of you might know, 5 steps: define, measure, analyze, improve, and control, right? So the first step is define the project scope. The question we can ask here are, let's see, what is the current problem to be solved? What are the goals and success criteria, right? What is the business case? Very important, right? What are the potential savings, the benefits, that will be realized once the project is solved or the project is completed. It's very important for us to quantify the potential savings, right, to justify the project. Otherwise, it just becomes merely a theoretical exercise. So making sure you have a tight business case is very important. And finally, who are the stakeholders? Customers, suppliers of this project. That's very important to identify. So once all these questions are answered, then we go ahead and establish a formal project, right? So what do we do there? Well, we make sure that the key stakeholders have agreed to the project charter, and there is a mechanism to track the project progress. And more importantly, we also have a mechanism to communicate the project progress across the organization. So there should be visibility. The customers and suppliers of the project should be made aware of how this project is progressing. That's very, very, very important. All right. So just to illustrate the point, let's consider a very simple case study. Let's assume that we are a furniture company, okay, and our retailers are unhappy with the quality of tables that is being delivered to them. So what do we do first? Well, we build a SIPOC chart, basically suppliers, inputs, process, output, and customer, and that's what they call SIPOC. Customers are identified by narrowing down, let's say, 5 retailers with the biggest issues, because let's accept the fact that we could have, I don't know, hundreds of retailers. So let's narrow down the list, make it manageable, and maybe pick the 5 retailers with the biggest issues. Estimate the cost of poor quality by considering the factors like, cost of repair, cost of reputation, cost of processing the claims, and more importantly, customer satisfaction. Now, I understand some of these factors are not very easily quantifiable, but at least we can get an idea of how much really it's costing us, right? So that's the bottom line. Then we identify the CTQ parameters, and many of you might know this. CTQ stands for critical to quality. To put it in layman's terms, CTQs are really what the customer expects of the product, right? So the spoken needs of the customer, that's what it is. So the customer may often express it in plain English, but really it's up to us to convert them to a measurable term, something that we can quantify, right? So CTQs, let's say, are what's a good product? How is customer satisfaction defined? It's very important to know that before we go any further. Then we define the scope, narrow down the problem causing the cause and effect diagram. And again, for those of you who might not know this, really cause and effect diagram, which is also known as a Ishikawa or a fishbone diagram, it's used to systematically analyze the root cause of the problems. You might also know the 5 why technique, right? So cause and effect also allows us to identify the root cause. And finally, map the process, right, from end to end, from manufacturing to retail. Again, that's what we call sometimes the values. Okay. Now, next step is to measure. Now, in the measure phase, really, first we identify the needed data, and the questions would be, what are the process inputs? What are the process outputs? And more importantly, performance measures. It's very important to get everyone on board with that. What is the information needed to monitor the progress of this project, right? Next, we obtain the data set. Is the needed measurement infrastructure already in place, right? Because we might not be able to measure what we need to measure. So we should have measurement systems in place. Is the data being collected and stored properly? It's very easy to lose the data or mix it up. So we need to make sure we collect it and start storing it so that later we can analyze it. Then evaluate the data quality. Does the measurement system yield accurate data? Garbage in, garbage out, right? So we need to make sure the data that we collect is precise and reproducible. Finally, we summarize the baseline data. Okay, so basically, the questions would be, what does the data look like upon initial assessment? Is it what we expected? What is what is the overall performance of the process, right? What assumptions have you made about the process and data? Let's document those. All right. So, excuse me. So what do we do in our simple case study as a part of measure phase? Well, we develop a data collection plan that decides who will collect the data, right? Data collection methods, and how will defect data be organized? Okay. So then we go on to collect the information about existence of damage, batch number, SKUs, location of damage, and so on and so forth, right? Then we validate the measurement system to make sure the data is good. We opt in multiple samples, very important, to make sure our analysis will be statistically significant. So it's very important to opt in multiple samples. Graph the data as a timeline, Pareto chart, histogram, box plot, whatever makes sense in that scenario. And then finally conduct the baseline analysis to determine the current state performance. Okay, so that becomes the current state, and that basically will make sure we understand the progress we are making going forward. All right. So in the analyze phase, which is next, the question to ask in the explore data phase would be, what is driving the variation, right? What is our new baseline? What are the assumptions associated with the revised baseline, maybe, right? Then we characterize the process and in that we basically ask, are there any hypotheses that needs to be tested, right? So what are the process map updates that we need, maybe? And are there any immediate issues that we need to address, right? And finally, we update the improvement project scope and define the scale at which we are operating, okay? So the questions in that case would be, is additional data exploration needed, right? Can I take action now? Or are there some evident improvements and corrections that I need to make first, right? And finally, maybe have I updated the project tracking and communication mechanism? As I said, communication is extremely important. People miss it all the time, but it's just not about the project team that's doing the project. It's also about the suppliers and the customers of the project. Actually, it's always about them. So it's very important to make sure we have a good communication system in place to make sure everyone knows what's happening on the project. All right. So back to our favorite case study then. In the analyze phase, we confirm the data types for each parameter. Maybe we conduct the ANOVA to identify and narrow down the source of variation if there are too many factors. Then we compare the loading process, the loading process information that we have, and maybe it turns out that second shift is really causing the main problem. And maybe it will, again, I'm just making all this up, right? So this is not a real case study, but it does relate to what can happen in real life. And so maybe as it turns out, 8 chips seems to occur more frequently than the phase chips or scratches. Okay, so now we're narrowing down to the root cause. Then we basically find out that the loading time and the force exerted on the table edges vary significantly based on the truck height, and maybe that's causing the problem. So now slowly we're getting somewhere with this. Okay, so but still remember we are still in analysis phase. Okay, let's keep going. Next one is improve. So here we identify the possible solutions. Questions would be, what are the solutions alternatives to address the root cause that we just have identified? What are the process factors to be adjusted? Okay. What is the viability of each potential solution? Because maybe we have identified, I don't know, 4 or 5 different solution options, but maybe not all of them are viable, right? So it's important to do the viability test. Select the solution and make sure we understand the relative benefits of the solution and also the potential risks and the issues that can cause maybe unintended consequences. So it's very important to think it through, okay, before jumping to the solution. Next is improvement, and here we basically ask ourselves, what is the action plan? What are the roles and the responsibilities? The timeline of the project, basically. And finally, can we quantify the benefits, right? Is piloting needed, maybe, to this widespread implementation? Maybe we are operating at a very big scale. So it might make sense to conduct a pilot first to make sure it makes sense, and then go on to the widespread or the full-scale implementation. And finally, they evaluate. Did the solution yield the desired impact? Has the goal been achieved yet? Okay. So, back to our little case study. Here now we brainstorm the idea to resolve the truck height, because remember we said truck height was really causing the variation, the pressure that was being exerted. So we said, okay, let's resolve the problem and let's see if we can generate some ideas around it. Okay. Now, once we have the set of ideas ready, let's validate those. Okay. Now, determine the effect of having maybe the movable platform or up and downstream activities. Okay. So let's think it through. Okay. Simulate maybe the scenario and perform the cost-benefit analysis. I mean, who knows? If you make a change, maybe that will impact the speed at which we are doing the operation. Will it cause a problem? So maybe let's simulate the scenario, build a simulation model, make sure the solution makes sense, it doesn't cause any throughput issues. Okay. Next, we conduct the FMEA analysis to consider the customer impact, narrow down the high ROI improvements, the one that we like, of course, and then map the future state. Okay, so here is how it's going to look like. Make sure again everyone is on the same page. Communicate it across the organization, and then if it makes sense, initiate the pilot, and collect the post-pilot defect data. Okay. Finally, once we are ready, implement it on all the docs. Create the control parameters. Okay, and create the error probes. POC, right? So make sure we catch the mistakes even before they occur. All right. Finally, the control phase. So here we define the control method, right? So does the procedural adherence need to be monitored here? That's very important to address. Then we implement it, and the questions would be, what updates are needed in the measurement infrastructure? What new process or procedure needs to be established? And finally, document the results, right? So have we documented the improvement project for for things like verification, sustainment of the initiative, and more importantly, or most importantly, organizational learning, because as a black belt or as someone who's leading the project, it's very, very important to know that we spread the knowledge, we spread the good word, make sure everyone understands that the project was successful, why it was successful, and that they can learn from it. So now we as a company can do this more effectively and easily going forward across all the departments wherever it's needed, basically. All right, so back to our favorite case study then. In the control phase, we implement the dashboard to record the defect information coming from retailers. We discuss with the retailers to set up a long-term measurement system, and then implement the control charts at both the dock process and feedback from retailers to ensure that the movable platforms are used effectively, and that the number of defects our retailers are within limits. Then we implement the X-bar and R charts, to monitor the entire delivery process. Again, monitoring is very important because we can quickly slip back to the status quo, where we started, right? So it's very important to, on an ongoing basis, monitor the process to make sure we sustain the improvement. Then we develop a reaction plan to identify any special causes from the process trends, outliers basically. And finally, we update and implement the SOP, which is basically standard operation procedure for the movable platforms. Again, standardizing it is very important. I couldn't emphasize more on this. Again, this ties back to the lean world. Lean is very big on standardization, and really the underlying concept of this is if you don't standardize it, then it's very difficult to measure the improvement. Make sure the variation goes away, because if everyone is doing it differently, really we are fighting I don't know, 10 different battles at 10 different fronts, right? Because everyone has maybe different problems just because they weren't doing it in a standard manner, right? So again, this is a good link between a lean and a Six Sigma. So as I said, I was going to touch upon this point just to kind of make you understand that these are all linked or technologies or methodologies that complement each other. They are not standalone. There is no reason for a Six Sigma specialist to fight with the theory of constraints guy, TOC guy, or a lean guy. They should really complement each other, because these methodologies are meant to be implemented that way. So how do they complement them? Well, theory of constraints, typically provides the focus for the lean and Six Sigma tools. So now we know where should we start the project, right? Because let's say you as a Six Sigma black belt walks in, and before you know, 10 different departments approach you and say, hey, listen to our problem. We are miserable right now. Help us. Well, but I mean, you have limited resources. So where should you begin? Well, it's good to use TOC and identify the constraint of the whole system. That's where you should begin, because that will make sure the impact, the improvement is substantial. And that way you can motivate everyone, right? Because once they start seeing this big improvement, they'll quickly get on board with you, and maybe the future projects will go easily, right? So So that's where we begin. Use TOC, theory of constraints, basically. Then Lean provides the solution for the problem, typically at the constraint, right? So we can understand if it's the inventory that's causing the issue. You know, it's maybe the standard work that's a problem. Maybe the workplace is a mess. So maybe we should do a 5S there. You know, so again, so Lean provides a solution for the problem at the constraint, typically. And then Lean also ensures that the problem will not return if implemented correctly, right? And then Six Sigma ensures that the quality, compliance, compliance of the process, basically, and variation issues are addressed, right? So Six Sigma believes, again, just to sum it up, in having a good, rock solid, dependable, or reliable process. Six Sigma doesn't believe in inspection, right? Inspection can always miss the parts. It believes that if the process is designed properly, if the variation issues are addressed, and make sure the process attains the reliability or dependability, then things will fall in place, right? So there won't be any rework, right? That we need to catch and spend time on. Okay, so that's a Six Sigma. So as you can see, I mean, these three methodologies really are meant to be implemented hand in hand or together, and as you can see, they complement each other nicely.